So now we're going to go on to the other kind of chi-square, the regular chi-square, where we have two categorical variables and we wonder if they're related. This is one of the most common statistical tests done in the world. It's a rare study that doesn't use at least one chi-square. So as you read journal articles, as you do analyses yourself, you will be using the chi-square and seeing the chi-square a whole lot. So in the case of the chi-square for two categorical variables, again, we'll be doing hypothesis testing. Our null hypothesis is always that there's nothing going on. So in this case, our null hypothesis is there is no association between the two categorical variables. And then the alternate is there is an association. We'll let the computer compute the chi-square statistic and find the p-value, and then we'll make a decision. But before we go into hypothesis testing, we want to check out what we've got. So here's a case based, here are numbers from a journal article from China, where they were looking at sex, male or female, and the severity of COVID-19, mild, severe, or critical. So the question is there a difference between males and females in how severe disease is? Is there an association between sex and severity? So do we have two categorical variables? Yep. Sex, male or female. Severity, they were classified as either mild, severe, or critical. So we have two categorical variables. We wonder if they're related, so chi-square is exactly what we need. One of our assumptions, if you recall, is that all of our expected counts are at least 5. So the top number is the actual count, the bottom number is the expected count. So we observed 5 males with mild disease. We would have expected 2 more than that. We would have expected 7 males with mild disease if the null hypothesis of no association was true. So we just check all 6 expected counts. The smallest one is 5.88. That's greater than 5. So yes, so we met that assumption. Simple random sample, well, it didn't say. So I just hope that these Chinese people in the sample, these 42 people in the sample, are representative of Chinese people as a whole. Because that's what inference is doing, saying, okay, we've got the sample of 42 and we're using that sample to draw conclusions about the entire population of Chinese people with COVID-19. And is there a relationship among all Chinese people between sex and the severity of the disease? So when we have a two-way table like this, you remember from chapter 3 that we first look at variables one at a time, just to describe our sample. Say, okay, well, we've got 42 in our sample. What percent of the 42 were male? Well, 23 out of the 42. So about 55% of the sample was male, about 45% of the sample was female. Okay, well, there's one variable. The other variable is how sick was our sample? Well, 42 people in our sample, 13 had mild disease, 14 severe, and 15 critical. So about 31% of our sample of 42 had mild disease, a third of them had severe disease, and 36% had critical disease. But of course that tells us nothing about whether there's a relationship between sex and severity. We've just described what percent are male, what percent are female, what percent have each level of disease. If we want to see if there's a relationship, then we need the conditional percents. We need to take things row by row or column by column. In this case, we want to see if there's a difference between males and females. So let's take it row by row. So we're going to look at the row percents, the second number down. So among males, we have 23 males. 5 had mild disease. If we go 5 divided by 23, it's about 22%. So about 22% of the males had mild disease. 6 out of 23, so 26% had severe disease. Over half, 12 out of the 23, had critical disease. Among females, 8 out of 19, 42% mild, 42% severe, only 16% critical. So it looks to me like there is an association, that there is a big difference. Over half of the males had critical disease, and most of the females were mild or severe, and only 16% critical. So based on those conditional percents, indeed it looks like there's a relationship. So let's test it statistically. Let's see if this is a greater difference than we would have expected to see just by chance. So our null hypothesis is there is no association between sex and severity. The alternate is there is an association, that there is a difference between males and females in the severity of disease. The chi-square statistic based on the StatCrunch output was 6.05. Degrees of freedom are 2. Now, in a two-way table, degrees of freedom are the number of rows minus 1 times the number of columns minus 1. So we have 2 rows, 2 minus 1 is 1, 3 columns, 3 minus 1 is 2, 1 times 2, we have 2 degrees of freedom, and the p-value is 0.0485. So now, of course, our conclusions depend on our alpha. If we picked alpha of 0.01, this would be greater than alpha, and we would not reject the null hypothesis. But if we pick our usual alpha of 0.05, our usual level of significance, then our p-value is less than or equal to alpha, we reject the null hypothesis, and we conclude that yes, there is a statistically significant association. Now, the chi-square test itself does not tell us the nature of that relationship, so if we want to know the nature of the relationship, we have to go back to those conditional percents. If there was no relationship, we would have expected these overall percents to apply to both groups. So we would have expected about 31% of males to have mild disease and about 31% of females to have mild disease. But that's not what we saw. Only 22% of males had mild disease and 42% of females had mild disease. If there was no relationship between sex and severity, we'd expect 1/3 of males to have severe disease and 1/3 of females to have severe disease. Well, that one's closer. We saw 26% of males with severe disease and 42% of females with severe disease. And again, if there was no relationship, we would have expected 36% of both groups to have critical disease, but that's not at all what we saw. This is where the big differences lie. Over half of males were critical, and only 16% of females were critical. So yes, there's a statistically significant association, and it looks like, based on the conditional percents, that's because males are much more likely to have serious disease. So a chi-square test, when we have 2 categorical variables, our null is that there's no association between the 2 categorical variables. The alternate is there is an association between those 2 categorical variables. In the population, of course, what do we think is true in the population based on our sample? The computer will come up with a chi-square statistic and a p-value, and then we'll look at the p-value and make a decision about what we think about the null hypothesis.